Director, uh, Dr. Satish Ubare sir, who has been a tremendous support and guiding force of our program. A guest of honor, Mr. Suraj Lekurware, and students of Matrix. Dear students, Matrix believes in leveraging the management competencies amongst the MBA graduates for businesses and industry by expanding their horizon with updated information in the field of management. In continuation with that, our Honorable Director, Professor Dr. Satish Ubare, has initiated Food Dimension Lecture Series, where we invite renowned experts from different fields of academic and industry who share their experiences with the students, which help them to improve their knowledge and employability skills. It is my pleasure to introduce a seasoned quality professional with nearly a decade of experience in the automotive and bearing manufacturing industry, Mr. Suraj Lekurwar. Mr. Suraj sir is currently serving as an assistant manager in supplier quality assurance at Texpin Bearing Limited in Gujarat. He brings with him rich experience from industry leaders like NRB Bearings Limited and Vorak Engineering Limited, where he has led multiple initiatives in quality system supplier development, and product audits under the IATF framework. A mechanical engineer by qualification, Mr. Suraj has a proven track record in reducing rejections, enhancing supplier performance, and driving continuous improvement using tools like APQP, FMEA, 7QC tools, 8D methodologies, and more. Beyond his technical expertise, he is also known for his leadership, quick analytical thinking, and commitment to excellence. Now, please join me in welcoming Mr. Suraj sir to share his insights with us today. Before starting, I would like to tell every students to please open up your cameras so we can have a group picture with sir. So I request you to please open up your cameras also.
Sure. Visible, ma'am?
Mohit, please let us know. Students, open up your cameras. Okay. Thank you. Over to you, sir.
Okay. Thank you, ma'am, for your brief introduction regarding my job profile. Uh, Firstly, good morning, students. And today our workshop is regarding the process and product developments regarding the in what we are doing in automobile industries. Okay. Yeah, the screen is visible.
Yes.
Okay. So, what is the process design and development? From your team, can anyone tell what is mean by this process design and development? Yes, team. I'm audible to all.
Yes.
Yes, yes.
Okay. Anybody is having idea? Just a minute. Huh? Whatever comes in your mind, you can elaborate, no doubt. We will go step by step for each and every points. So it may be wrong, it may be right. Anything what is related to your concept regarding process design and development. So you can share your thoughts. By that, we will link up these sessions and we will move forward, because it should not be one-way interactions. I want some inputs from your side also. Some inputs I will do share, and then we can move forward with this. Actually, I have all the details which is there in this presentation, but it will be a two-way interaction session. So whatever you are getting thoughts in your mind regarding the process design and development, how it is been carried out in terms of any field, not only automobile but any different fields which you can have an expertise, or you have seen any processes, you can elaborate. So anyone can share his thoughts, so we can move forward. Team. Okay, so can we start? Hello.
Yes, sir. Yes.
Okay, fine. Okay, you will get one by one discussion while we are moving forward with reference slides. You will get the idea how this process has been designed and developed as per the industrial automobile sectors, and what are the key points which we are going to see today during the development of a new process or new part in automobile industry, right? So what is the basic of product quality planning cycle? So this we called in our automobile sector as PDCA cycle, means plan, do, check, and act. For development of any of the part, first and foremost, we need to have a clear and detailed plan, which we called as an plan and define, means technology and concept development in which it is been included, right? Then after the planning has been happened, we start on working on it, which means that we are doing product process development and prototype verification. So during any development of the part needs to be go through the product design and development, means what we can call this as the product design and development. So during the part develop initial stage, the what is the core roles the part is going to play, what will be the dimension of the part, what will be the height of the part, what will be the length of the part, or we can say the weight of the part, how many different child parts is going to be get assembled in that particular part. That all concept has been studied in product design and development and process design and development. So moving with the forward with process design and development, what design parameters should we need to be take under our control for developing that particular product? It has been to be examined. So this is the total two different concepts of product design and development and process design and development, right? Then moving from product design and development and process design development to the next stage is the product and process validation. See, if you develop any part, it needs to be validated after fully developed of that particular part, right? So what in the terms of validation will be taken, that we are going to discuss in this particular session. And then after doing the validation of that particular product, the feedback assessment and corrective actions, means the end product which we are delivering to our customers. We need to take the feedback from a customer regarding what is the life of that particular product. Is that product is working properly, which we have developed? Is any corrective actions needs to be taken? Is any failure part found in that particular part? So this all terms we need to be considered during any product design and development. This side is clear to everybody? If you are having any doubt, please raise your points. We will discuss in detail about that particular point. But as of now, this is the basic things which I have made into a PPT to know what is the basic of product design and development, how the product life cycle is been getting move forward. So particular for this slide, is any issues is there? Please discuss. Or you are clear with this? Yes, team. Hello. एक मिनट. Clear? Should we move forward with the next slide? Hello. My voice is audible?
Yes, sir.
Okay. Can we move forward then? If it is clear to you?
Yes.
Yes.
Okay, fine. Just a minute, just a minute. Okay, sorry. Uh, okay. So this is our next cycle regarding the product quality planning responsibility matrix. See, before defining any part, we need to give the proper responsibility to each and every our team member. So what is basically this slide is talking about? The metric shows below despite the product's quality planning functions of three types of organization. It is to be assessed organization and defining the scope of their planning responsibilities. What just before I have told. Refer to the fundamentals of this product quality planning. Next page. Okay, that we will see. The matrix does not depict all the different types of products quality planning relationships that could exist among organizations, suppliers, and customers. So what we have seen in the previous slide that define the scope of the product, the plan and define chapter. In that we have seen the product design and development, how it has to be carried out. Then the feasibility section will be there. The process design and development will be there. After product design and development, then validation will be there, the feedback will be there, and then it will be the control plan methodology that I will share you. Okay. So moving forward with the next slide, what is the basic fundamentals of product quality planning? See, the basic of the fundamentals are the product quality planning is a structured method of defining, establishing the step necessary to assure the product satisfies your customer. Means what we are trying to do, we are trying to do such a product, means we are trying to develop such a part which will satisfy the customer requirements. If the customer means, you can keep in your mind that customer might be anyone that is from Tata, then it is from Mahindra. In automobile industry particularly I am talking about, it is from Tata, Mahindra, or some other Maruti Suzuki, that are that all are our customers. So we need to satisfy them, we need to satisfy them regarding giving the proper quality products. So the goal of the product quality is planning to define the facilitate communication with everyone involved to ensure that all requirement steps are completed on time. See, if the product needs to be completed and the customer has given us the 3 months of time frame, that your product needs to be complete within 3 months with all the trials and errors at your end. So we need to define our systems in such a way that in a 3 months period, the product is been getting properly validated and it must be go to the customer with defect free, right? So if next point I am trying to tell you that effectiveness product quality planning depends on a company's top management commitment to the effort required in the achieving customer satisfaction. Some of the benefits of product quality plannings are to direct resource the satisfy the customer. This is the what I'm first also I have told you earlier also, that the we need to satisfy the customer. So for that, whatever time frame we needs to be defined, whatever trials we have to taken, that has to be taken within that time frame, and the customer should be ultimately get satisfied with the quality of the product which we are supplying to him. right? To promote early identification of the requirement changes. Means if while developing any product, there might be some lacuna, or we can say there might be some errors during the product development. So to identify that earlier changes or any required changes is there during the during the manufacturing of product, that to be identified to avoid late changes. See, if we done any product and it has been developed till the last stage, and then we found that some changes is there in at the customer end, or the bearing or any other product has been get failed at customer vehicle. So that time we cannot change that particular product or say that the design is not appropriate. So to avoid that any late changes at the customer end, we need to go from the basics of the PDCA cycle, which earlier I have told you. Okay, to provide a quality product on time at the lowest cost. See, in this now the scenario of the market is customer is demanding us the low cost part with good quality standards. So for achieving all that, you need to have good APQP process. Means what we are saying right now is the part development process. So that process has been need to be go through very thoroughly, and by using all the principles and all the concepts of product development, we need to develop the product in such a way that it should be at lower cost and with better quality, right? To work the work practices, tools, and analytical techniques described in each of the manual are listed in a logical sequence to make it easy flow. Each product quality plan is unique. Means if the part is different, the quality plan will also be different. It will not be the same. The details, the fundamentals, the analyticals, the calculations, that all things will be get in a different manner for developing any other part, right? The actual timing and sequence of the execution is depend on customer needs and expectations. Means, see, the as I earlier also told you that the customer is god for us. Means any changes or any development needs to be go through customer only. If the customer is okay with the part which we are produced, then it is fine. But if we need any changes or any controls or any addition process at his part during development, we need to ensure that. Okay, the earlier a work life practice tool analytical techniques can be implemented in the product quality planning cycle, right? So see the points which needs to be considered during design and development of any new part. Okay, we are at the basic right now. We are trying to form a team of this for this particular part, right? So what we will do during the development of the new part, or during the initial stage of the part, that first we need to organize a team. See, organizing a team is not only of the quality person or any production person, any of terms. It is will not be only of the age group of 10 to 12 or 20 to 30 like that. It will not that organizing the team. Organizers of the team should be such as it one person should be there from quality, one person should be there from production, one person should be there from design, one person should be there from purchase, one person should be there from finance, there should be a one plant head in that team. Means all CFT team, what we call it as CFT team, that cross functional team, means all the members from different expertise, they should be taken into consideration during development of any new product, right? So next point is defining the scope. See, after deployment of the team, we need to find the scope of that product. Means how the product is going to be fit in during our assembly or customer part assembly, where the product is going to be fit, what would be the RPM of that product, how the rotation of the product will be considered, what will be the function of that particular product. See, this all things we will needs to be considered during development of the new product. Then next term is team to team. Means there will be the different teams working on the different areas during the development of the product. One team will be work on the purchase, one team will be working on the finances, one team will be working on the quality, one team will be working on the production. That all the cross functions teams, there should be proper understanding between the teams. The next point comes is training. See, we cannot blankly form a team and start working on that particular product, but for that we do need have a proper training of that particular product. Means how the product is, the life cycle is going to be established, and what are the technical points which may comes during the design of the product. For that details, the proper training has to be given for all the team members, right? Then customer and organization involvement. Suppose I am working right now in Texpin bearings and my customer is Tata, right? So the my team top management involvement should be there during the development of the new product, and customer involvement should also be there. Means single way I cannot work for development on a product, or single way customer also cannot say that you have to do this product by this measure or this measure. The collaboration approach between the two teams should be there for development any good product. Then after that, simulations. During the product design and development, some simulations we have to calculate. Means some trials, some what we can say, some prototype samples, or prototype samples. Yes, prototype samples we have to make to do the simulation on that particular product in order to get our product right at early stage. Last minute failure is always dangerous, so to avoid that we are doing simulations on our products. Then it comes to the control plans. It is the basically the bible, or what we can say the Gita in engineering. Means the control plan is the mother document of every product, so that control plan needs to be planned. Then concern resolutions is come. Means after doing all these things and developing the parts, is any concern found at end, is there any concern found during last stage, that should be resolved. Everyone is okay with till this, or any questions is there? We can answer right now only. Are you getting each and every point, students?
Yes, sir. Got it.
Okay, fine. Then we will move to the next slides. See the first slide. If you remember that we have seen the PDCA cycle. So we have we have made this slide for having the proper understanding to you that how the plan and define program when it will be start. See, you can see to the left corner the concept approval, means the planning of that particular part. Then after planning we are going for the product design and development. After product design and development we are moving forward with process design and development. After process design and development we are doing with product and process validation, and then we are going for the mass production. Without planning, without designing product design and development, or without validation, we cannot move for the production, which will cause the failure of that part. You try to understand, students, that if the part has been gone through these 4 stages, then we will see, then we can able to find what are the difficulties which caused during the development of the part. If the part we are skipping any one of the stages during the initial development of the part, which will ultimately result to the product failure at last stage. So while planning, while design and development, while product design, while validation, what are the points we need to be considered, we will see in our next slide. Okay, so this is the chapter 1, plan and define program. See, during the planning, what stages or what actions we need to initiate, that we are going to see. During planning, the design goals need to be clear. How the part, what would be the design of that particular part, what will be the inner diameter, outer diameter, or any radius is there, what are the concepts or challenges we are going to face during that particular part. So design goals should be clear. Then reliability and quality goals. What quality standards we need to keep in the mind during this particular developing the new part? Is that part is going to the aerospace, that part is going to the four-wheeler, that part is going to the two-wheeler, or that part is going to be going in quality bicycle. So if the part is going to fit in the aerospace, we need to have the good quality goals or quality standards, right? As compared to bicycle. So these are the different concepts. What are the things you need to the what additional things you need to the put during that part development? Then it comes to the preliminary bill of material, which we called in our automobile sector as BOM. So what is the bill of material? So what is the cost of that particular part? From where the part raw material is going to be purchased? What is the time frame the raw material supplier is going to be deliver the particular raw material to us? What steel he will identify? What would the hardness of that particular raw material? That all concepts you need to find in bill of the materials, means at initial planning stages. Okay. Then preliminary process flow chart. See, during the development of any part, we need to clearly define the process flow. Means during the part development, we directly cannot jump to the hobbying or shaving, that kind of operation, or any final grindings. That operations we cannot do. So for that, we need to have a proper process flow. Means the raw material we will consume, we will have the hot forging or cold forging for that particular part, then we will do the machining for that particular part, then we will do the hobbying or any say the shaving for that particular part, then we will do final inspection of that part, and then we will supply to our customer. So all that the process flow needs to be clearly defined before planning, means before development of that part, right? Primary listing and special product and process characteristics, means what we can understand from this point, that some part during development stage needs to be given proper attention. Some process, critical process or the product should be identified, which will directly hamper our product design during at customer stage or at final stage. Means that diversion during that particular product and process should not be there, which will reflect the life of that particular part. So we need to identify that special product and process characteristics during planning itself, right? Product assurance plan. What will be the inspection frequency? What are the checking methods we are going to implement? That all you need to assure in product assurance plan. And of course, the last point is management support. Not a single part cannot be developed without our top management support. They have to involve during the development of any new product, right? It is clear till now? Okay. Shall we move forward, or any confusion regarding this particular slide?
No, sir.
Fine. Okay. So that just I have briefly discussed you in this previous slide. The inputs is voice of the customer, market research, historical warranty and quality information. See, what is the warranty, that how that our part is going to be give the life of that particular part for let us say about 5 years, 10 years. See, what government is doing is they are telling us that your vehicle is being get authorized for next 20 years. Means what they are telling, that your part is being getting validated for next 20 years. So that warranty the company is defining to the government or any other OEMs, means like Tata, Mahindra, that during initial stage, the part which is going to develop, that historical warranty we are defining to our customers, right? Then team experience, business plan, marketing strategy, how will be the business plan, process, product benchmark data, the assumptions, what some certain things we need to assume during development any part. So that assumptions also needs to be taken into consideration. Then product reliability studies. Is that my product reliable? Is that my product is going to achieve the desired conditions? Is my product is going to act as free in different temperatures? What we can say that minus 20 degree or plus 40 degree. My product, the life of my product is not getting divert. So that concept is needed to be studied in product reliability studies. Then customer input. See, during development any part, customer is also giving us the inputs. Means they are also telling us that you changes the radius of this particular part for getting proper fitment, or increase the number of balls in that particular cages to get proper rotation on bearings. I'm talking about the bearings. So this customer also giving us some inputs. So based on these inputs, we are doing changes in our particular product. Then what will be the output of such inputs is design goals we will achieve, reliability and quality goals we will achieve, preliminary bill of materials we are getting all details, process chart will be identified, special product and process characteristics will be identified, and product assurance plan we will follow. Okay, till now, is any confusion is there regarding the inputs and outputs, and what is the initial stage of the planning we are doing for designing of the any product? Is there any confusion, team? We can discuss right now, because see, during the development of the part, we need to have a proper planning, and for planning we have to take all these points into the consideration, starting from design goals to management support. In that also the some inputs is there, that inputs is also needs to be taken, and after consideration that all particular inputs, we will get the desired outputs. Okay, so if we start during the product development, if we start working out the inputs and minimize the gaps during the inputs, then we can achieve the proper output in planning stage. This is the first stage of product development, planning. So by consideration all these points, we have got the proper planned product, right? Is there any doubt, or can we move forward? Hello, can we move forward? Yes,
Yes.
team, all are there with me?
Yes, yes.
Are you understanding?
Yes, sir.
Any issues till now?
No.
Okay, fine. We will move. See, from the output, the voice of the customer that I have recently told you, that market research needs to be there, historical warranty and quality information should be there, team experience should be there, business plan and marketing strategies, product process benchmark data. You need to find the gaps during the product and process benchmark, right? Product process assumptions, new technologies to be used as inputs. Means during the assumptions of any product, we are assuming certain things, but on what basis we are going to assume? For that, we need to have advanced technologies that will calculate and give us the result that this part is going to failure at this particular cycle. So you have the clear assumptions that if I use this type of material or use this type of the process, my part is not going to fail. Then there is the customer input, as earlier I have told you. Then bill of materials, process flow chart, preliminary identification of that earlier only I have discussed with you. Okay, so is there any issue with the first chapter? What is the first chapter? Planned and defined program. So in that we have planned and defined the program, means we have taken proper planning, we have given we have defined that details and given that details to our customer. We have defined the team, we have taken the support, we have found the proper what we can say the marketing strategies, the historical warranties, the customer inputs, the product and process assumptions, that all the things we have identified, right? So from moving from chapter 1 to the next stage is the process design and development. So from here our part is starting our part is going to start in production, means is getting produced from first stage to second stage, right? Just a minute. Huh? Okay. So after planning, we are moving forward with product design and development. So this is the same chart. First, the highlight was there in the planning. Now we have highlighted in product design and development. Okay. Just a minute. Okay. So in the second stage of product design and development, what factors we need to be considered, that the details is there in design outputs, design failure mode and effective analysis. Means during the development of the product, what are the failures may occur during the product design, that we need to be analysis. See students, this concept is widely used in aerospace industries. If we see the while launching any rocket launchers or any satellites in the space, how much they need to be have a design failure mode effective analysis. Means what are the modes that the satellite or that missile may get failure. So thinking about that, what are the concepts for by which the parts, our part will get failure? Is there any external things or the part design is there going to failure? That all the concepts we need to identify earlier only in order to achieve the good product at last stage, right? Then design of manufacturability to assembly. How would be the design for manufacturing till the last stage? What are the points or inputs we are going to provide during manufacture and assembly? Then we design verifications. Then we will find the design reviews. Okay, then proto build samples, means this is the primary control plan which we say during development of the part. Then engineering drawing, the new drawing will be there for developing any new product. Then engineering specification, what we can understand from engineering specification is that what tolerance is being given on the particular part, to find what tolerance is given to the particular part in order to achieve the final result output. Then material specifications, means what percent of chromium, iron, carbon should be there in the particular part, so that it not get failure in while driving the car or any other certain obstacles. So that all things we need to be properly identified, right? So what is the chapter second tells about? The chapter discuss the elements of the planning process during which design features and characteristics are developed into a near final form. All the design factors should be considered by the organization in the advanced product quality planning process, even if the design is owned by the customer or shared. Means if the design is of the customer, then also we need to have the proper product quality planning process. Means all the aspect need to be properly checked, properly defined. If that design is of customer also, if our design is there, we have to do that particular thing. But if the design is there of the customers, for that also we need to do proper APQP, means product quality planning process. Okay. The next step includes prototype build to verify that a product or service meets the objective of the voice of the customer. See, before dispatching any final product, we need to have the prototype, means what we can say a duplicate of that particular product. So that needs to be verified or built with the help of the customer and get approved from the customer. A feasible design must permit meeting process volumes, schedules to be consistent with ability to meet engineering requirements. See, any development of the part, it should be developed within 6 months of time frame. But if we consider the design and the proper development of the part, it should not be extent of the part will ultimately leads to the frustration of the customers, right? The customer is not happy with taking long time of that long time during the product of the during development of the particular part. So these all the challenges should be taken while development of the part. Then it comes to be the quality, reliability, investment cost, weight, unit cost of that particular part. Okay. Although the feasibility studies and control plans are primarily based on the engineering drawing and specification requirements, valuable input can be derived from the analytical tool described in the chapter to further define and prioritize the characteristics that may need special product and process controls. In this chapter, the product quality planning process is designed to assure a comprehensive and critical review of engineering requirements and other related technical information. What we have studied during this chapter second, that we need to find the critical processes, we need to have the comprehensive study of that part, we need to find the engineering requirements of that particular part. At this stage of the process and preliminary feasibility analysis will be made to assess the potential problems that could occur during manufacturing, right? So what will be the inputs? See, the inputs will be of this is of chapter 1, means design goals, reliability and quality goals, primarily bomb, that we have find in first chapter. We have taken that all inputs for going to the second chapter, right? So what will be the consideration, all the inputs of from first chapter what we have studied, we are going to the next stage, that we need we have found develop proper DFMEA, means design failure mode effective. We have proper design, manufacturing and assembly, design verification we have done, we have reviewed our design, we have built a prototype control plan. Means it is why we are saying is as prototype, because that is the not final control plan. The control plan, final part designs, final controls is not yet established, but we have established is in a prototype, means there might be some changes before final control plan, right? So engineering drawing including mathematical data, that of course it will be there. Engineering specifications, material specifications, drawing specification change. So what is the output of that, this all stages, that new equipment, tooling and facilities requirement. See, if we consider all the things and try to find out what are the things we need to find, or extra things we need to have during the design of new product, so it can be found out that new equipment or tooling we are required, special process and product characteristics we are required, we require gauges and testing equipments to develop that part, we need team feasibility, commitment and management support to do that particular part. Okay, is it clear till now? This is all the details, that design failure mode effective analysis, what I have just discussed with you all regarding the design of manufacturability and assembly, design concept, function, sensitivity of that particular part, manufacturing and assembly processes, dimensional tolerance, it has to be defined now, number of components, how many child parts is going to be fit in that particular part. In terms of bearing, we can say that cages, needles, rollers, what are the child parts is going to produce a particular bearing. So that number of components is what components are there to manufacture a particular part. Then process adjustment, what are the process we are changing, what are we doing the adjustment in the process, what the what we can say RPM we are extending or making it at the lower side. Then material handling, how the material is going to be handled, what would be the movement of that particular material from one stage to other, that also needs to be defined. Then design verifications, product design meets customer requirement, that it is the same design verification and meeting the customer requirements. Then design reviews, design reviews are regularly scheduled meeting led by the organization team. See, we are developing the particular part, but we need to have the properly design reviews also during development. At final stage is before failure any part at final stage, step by step we need to have a design reviews. Are we working on a right track? Is any problem is going to occur, or we are misunderstanding any concepts? This all the terms or customer inputs is there, means customer is also supporting us or not. So this all the things we need to be considered during design reviews, right? Then prototype build control plan, that previously only I have explained you. Then engineering drawing, engineering specification, material specification, drawing specification, new equipment tooling facilities, and special product and process designs. So these all things we have to take into our consideration during development of the part in second stage, right? Are you getting my points, or any confusion is there? See team, I need inputs from your sides. Is you are understanding or everything, or it seems that you are understanding nothing? Two things can be happen if the inputs is not there from your side.
No, sir, no problem.
It is not, it should not one side interaction, friends. The interaction should be from both the sides. I do know that you are having this is what something new to you, but if there any doubt, any what we can say, any issues is there to understand you, I'm going too fast, if any points is not getting up to your mark, you can just speak it out. We can discuss in detail about that particular part. Okay, if any doubt is there, do speak, right? Can we move forward? Is everything is clear till now?
Yes, sir.
Okay, fine. See, now in chapter 2, what we have seen, we have developed the process design and product design and development. We have given the tolerance, we have taken the bill of materials, we have established the process, we have seen the process flow, we have done the FMEA in the chapter 2. So during chapter 3 for process design and development, the what things we have done in chapter 1 and chapter 2. In chapter 1 is planning. What planning inputs we have taken. In chapter 2, product design and development, what are the things we have identified and what things we need to be addressed. That all things will come now in chapter 3. Okay, so these two things will be the input for now process design and development. We cannot do process design and development and then we can design the product. We have to do product design earlier, then after product designing, after achieving all the desired results, we can move forward with process design and development. These both concepts are different. Always keep in mind that process design is different and product design is different. You cannot combine these two concepts, as the end results of the product or feedback from the customer gets hampered if you compare process design and product design and try to do it simultaneously manner. Okay, so now we will study the process design and development. See, the same slide is there. First we have done planning, then we have done the process design and development. Now we are going for product design and development. Firstly, the concept approved is there, then program approved is been there, then prototype is also made. Now what we are doing in process design and development, we are making the pilot lot. Means what is the basic of pilot lot? The lot of 500 quantities or 1000 quantities as an pilot lot, means as an small lot we are now developing and they're giving that particular lot to the customer. So this is the particular definition of the pilot lot, right? So now in this, what we are considering, the chapter discuss the major features of developing and manufacturing system and its related control plans to achieve quality product. See, what is discussing here now, we are now here to develop the final control plan, means final dimensions, final controls we are now establishing on the particular part. This task to be accomplished, the task to be accomplished at the step of the product quality planning process depend upon the successful completion of the prior stages. What I have previously told you, that after successfully completion of the product design and development and planning stage, the third stage can be started, right? The next step is designed to ensure the comprehensive development of the effective manufacturing system. The manufacturing system must assure that the customer requirements needs to be expectations and needs to be expectations are made, means customer expectations should be made of by by analysis and defining first two stages. The inputs and outputs applicable to the process step in these chapters are as follows. See, what would be the inputs of this stage is the output of second stage, means what we have discussed in second stage, that DFM is there, design manufacturing and assembly is there, design verification will be there, design reviews will be there. That all the stage, that output of second stage will be considered as the input for the third stage, that is process design and development. And for designing of the any process, what would be the output? That packing standard and specification, process flow, process and product quality system review, process flow chart, floor layout, characteristics metrics, FMEA, pre-launch control plan, product instruction, MSA, preliminary process capability study, and management support. So based on all this input, what outputs we are going to achieve is all there in third stage, that is product process design and development. Okay. So in process design and development, what we are trying to do now, we are getting into the packing standard and specification, means during what is the packing standard, how our product or process or part is going to be packed. It is going to pack in 100 quantities, it is going to pack in 20 quantities. What would be the space between the two components, how the carry bag is going to be handled, how the packing is to be done of that particular part, that needs to be addressed in details. Then second point is product and process quality review. So is my product and process is going up to the mark? I am reviewing that particular quality of that process and product, that also needs to be analyzed. Then process flow chart, is my product and process is going as per the process flow chart, that also we need to find out. Then floor plan layout, means how the material movement of the particular part is going to be done. Then FMEA, I have earlier also told you that what failure modes can be affect, that we have to take into consideration. Pre-launch control plan, it is the prototype control plan. Before final part launch, we need to define pre-launch control plan. Then MSA is the different concept for inspection of the any particular part. So it is in quite in detail, but just overview I am telling, it is the measurement system, systematic analysis, right? So how the part is going to be measured, what tolerance is there in the particular part, that we need to find in MSA. Then preliminary process capability study, what we can say it is PPAP. Means there are also different documents in PPAP that we need to be understand, and we need to have a detailed product manufacture. Okay, till chapter 3. In chapter 2, what we have done, we have designed the product and we have reviewed it. What in chapter 3 we have done, we have designed the process and we have reviewed it, means how the process by where the part is going to flow, what are the controls during the part production, that all the things we have seen in third stage, which is process design and development, right? Is it clear till now? Students, you are understanding or not? Hello. I'm audible? Hello.
Yes, sir.
Okay, fine. 74 students are there and 1 and 2 students only replying. Okay, we will move forward with next is process and product validation. Any doubt? Can we move forward? Hello. Hello. Are you get students? Are you getting or any doubt is there?
No,
Students,
sir, no
is there
doubt.
any doubts you can ask, sir?
Okay, we will get now for product process validation. Okay, so till now we have done the process design, product design, the part has also been manufactured, and now we are going for the final step is validation of that particular part, right? So what key measures we need to be keep in mind during final validation of the part? So we are getting going into the introduction of product and process validation, right? So this chapter discusses the major features of validating the manufacturing process through an evaluation of significant process run. What we are doing now, we have designed the product, we have developed the product. Now we are going for the production of that particular part. So we what is he is trying to say is telling that we are going for the production run at a batch quantity. During the significant production run, the organization product quality planning team should validate that the control plan and process flow chart are being followed and the products meets customer requirements. Means what is trying to say that the product quality planning team should validate that they have the final control plan, final process flow chart, and by controlling all that particular things, the final product is going to be run. Additional concerns should be identified. Additional concerns should be identified for investigation and resolution prior to the regular production run. Hello. Okay. So additional concerns should be identified or investigation should be there at the prior before final mass production. So the inputs of this is it will be from third stage, that is process design and development, such as packing standards, product and process flow, then process flow chart, process plan, that all things we have studied in chapter 3. So what will be the output of this is a significant production run. We have validated all the inputs of from chapter 3 and we are going for chapter 5. The outputs will be in chapter 5, but what would be the output? That significant production run, measurement system evaluation, what we say as MSA, preliminary process and capability study will be there, product part approval will be there, production validating testing will be there, packing evaluation will be there, and production control plan will be defined. Okay, so all the inputs from third stage is going to be validated in fourth stage, that is product and process validation will be there, and it will be get the outputs in fifth stage. So what will be the production run? That only the significant production run must be considered using production tooling, production equipments, production environment, production gauges, and production rate. So this all consideration, this all things we need to be consideration during manufacturing of batch quantity. Minimum quantity of production rate is set by the customer and outputs are. See, the customer now you will be he's telling you that I need the batch quantity of 500 quantities or 1000 quantities. That will be decided by the customer. So for that you need to have the process capability you need to have a MSA, you need to have a production rate, you need to have the production review, then you need to have a production validation testing. This all the things you need to have during the batch production of that particular rod. See, the last point is somewhat different. Sorry. The last point is somewhat different is master samples. It is the first sample which you are manufacturing in your line, and you are handovering that particular part to the customer as a master sample. That part is particularly will be examined by the customer, and he will give the outputs after dimensional and metallurgical inspection at his end. If that any lacuna is there, he will try to correct you at the fourth stage itself, that is validation stage. Okay. Is it clear till fourth stage? Now we are going to the last stage of the APQP, that is feedback, assessment, and corrective actions. See friends, we have done the planning, we have done the product design, we have done the process design, we have done the validation of the product. The our product 500 quantity or 1000 quantity is been get approved at customer end also. But after that also, is any feedback is there or any corrective action is there after the final development of the product, it needs to be taken into account. Okay. So this is the last stage of product quality planning cycle, is launch of the product. Means we can go for now the mass production of 1000 quantity, 10,000 quantity, 20,000 quantity, or 1 lakh quantity. So after properly design and development of this part at stage wise, and after proper validation of the part, we are going to launch that product, particular product in market, and then we are going to do the mass production of the part. Okay. So this is the fifth stage, what is saying about the feedback, assessment, and corrective actions.
Hello.
Yes,
I'm
Mrunal.
sorry to interrupt, sir, but we have already surpassed the time limit. So can we just wrap up?
Okay, ma'am. Just 1 or 2 slides.
Yeah,
Okay.
no problem.
We will
Yes.
do it in most 10 minutes probably. Okay. So the quality planning does not end with the process validation and installations. Means what we are doing here the final outputs which we receive from the customer, that significant production run, measuring system evaluation we are doing preliminary process capability study, the validation and packing evaluation, that all the things may affect during the final output of the customer at line stage, means during field stage it may affect. So that what he's trying to say us customer, that you need to have the proper controls on all these things. So what will be the output? It will be reduce the variation, improve customer satisfaction, and it will be improve the delivery, right? So just going at the conclusion from all this stage, what we are trying to do in the fifth stage, we try to reduce the variation, improve customer satisfaction, improve delivery and services, and effective use of lessons learned. So what are the 4 things we have done previously? We are going to what we can say, we are putting in effort in fifth stage and try to control all the things and give the proper product to our customer. Okay. So it is clear, team, or any doubt is there, you can ask right now. We can resolve it. Okay, Mrunal madam.
Students, if there are any doubts or questions regarding the development and the process designing, you can freely ask.
Hello. Hi, sir.
Yes, sir.
What are the main like major timelines for the process design and development?
See, major timeline is depend on the customer and critically of the part. If the part is too critical and not getting achieved, so the deadline can be extend up to 1 year, but usually it is been squeezed up to 6 months. you can see in the market the new vehicles is been getting in every 1 or 2 years new vehicle is getting launched. Okay, so they are giving that much time to develop that particular vehicle, or 6 months or 1 year, and then that after designing and development all these things, they are going for the mass production. So usually from 6 months to 1 year it will take.
And what are the critical parameters to be measures in the process development and design?
Critical parameters is the function of that part. See, during the development of the part, let me tell you about the bearings. It is going to assemble in shaft, right? So you need to have the proper interference feeds in that. The shaft OD and shaft ID and bearing OD should be properly interference. So that would be the critical parameter in that. Then in terms of the bearing, the freely rotation of the bearings will be there. So it should be rotate freely. The main function of the bearing is should be freely rotate and not to get jammed. If the bearing is get jammed, the life of the particular product will be drastically reduced. So that free rotation, free revolution, and somewhat we can say about the aspects of radius, chamfers for proper fitment, that all are the critical parameters, but it may vary depend upon our product, our design and application.
Oh, okay, sir. Thanks.
Is anyone else there who wants to discuss something about the topic? Okay, I think there are no questions, sir.
Okay.
Can we wrap up, sir? Hello?
Okay, ma'am, fine.
Yeah, okay. Thank you so much, sir, for accepting our invitation
Thank you. Thank you.
and for sharing such profound insights on workshop on process design and development. The session was really very informative and very wonderful, as students really enjoyed the session. So on behalf of Matrix School of Management Studies, I thank our guest of honor, Mr. Suraj sir, for guiding the students. I thank our director and express my gratitude for your support and direction throughout the session. Thank you so much, sir.
Okay, ma'am. Thank you.
And students are requested to fill the feedback form and then you can leave the session. So you can log out
Okay.
if you can.
Okay.
Yes. Thank you so much.